Hi. The first thing we have to do, or be able to do, in order to balance equations like we did in class, is to be able to count up the number of each individual atom inside a molecule. Here's a molecule that's familiar to us. It's water. It is actually an H stuck to an O stuck to an H. Now, it doesn't matter at this point in the course that you know how they're stuck together like that, but it does show that this subscript shows that there are two hydrogens. Now, there's a subscript here they never write, which is a 1, showing 1 oxygen. So in a water molecule, there are 2 H's and 1 oxygen. This molecule here, C2H6, well, that subscript means there's 2 carbons and there's 6 hydrogens. It can get more complicated. For example, a molecule like this, where we see that there are hydrogens here and there. Now, it may seem weird that they wrote them in separate spots, and as we go through the course, you'll understand why they did that. But for now, we can see that there is 1 plus 3, there are 4 hydrogens. There's a carbon here and a carbon there, so that makes 2 carbons, and there are 2 oxygens. Another example that you might see is when they write molecules is things like this, where there'll be a parenthesis, okay, and a subscript. Now what that means is the Fe, the iron, has a 1 there that's not written, but this parenthesis with the 2 means that you really have a molecule like this. Now you might wonder why they didn't put the 2 there and there, since this 2 outside the parenthesis means the whole thing happens twice, and we'll learn why that is later, but it does show some grouping within the molecule when it's put together. So in this case, you have 1 iron, you'll have 2 O's because there's a 2 there saying this parenthesis happens twice, and you'll have 2 H's. Another more complicated example, maybe something like this. This says you have 3 calciums, so this is really something like that, and 2 of this whole thing inside the parenthesis. So to count those up, now I know that this thing inside the parenthesis is 2 separate atoms because they're both capitalized. So there's a phosphorus and 4 oxygens. That phosphorus 4 oxygen group happens twice. So let's see, that makes 3 calciums. It makes 2 phosphorus, and it makes 8 oxygen. Another thing you'll encounter when you're trying to balance equations is instead of subscripts, you might have something like this we've just talked about, where you have a subscript out here. You might have a number in front, which is called a coefficient. Now what that means is the entire thing happens twice. So if you count the number of calciums, there's 1 inside the box, there's 2 oxygens and 2 hydrogens because of the parenthesis and the 2, and this entire thing happens twice. So it's almost like a distributive property where now there's 2 calciums, there's 2 times 2, 4 oxygens, 2 calciums, 4 oxygens, and 4 hydrogens. That's another thing. The numbers in front, the coefficients, that's what you use to balance equations. Now, it's really important that you understand that if you have something like this, H2O, that we're very familiar with, and you have another molecule like this, H2O2, those are very different. H2O is water, H2O2 is hydrogen peroxide. And actually a pretty dangerous chemical if it's not used correctly. When we balance equations, we're going to put numbers in front, coefficients. We are not, if we did a balancing equation and we needed 1 more oxygen, I can't just put a 2 there because I've changed the water into something else. If the water molecule is what is made or what is used, then we cannot put subscripts, we can only put coefficients. So let's look at how you balance equations. Here's one we saw in class today. Hydrogen plus oxygen makes water. So what you have here is a hydrogen molecule and an oxygen molecule, and it doesn't matter right now how I knew that there was a double bond or 2 sticks for the oxygen, and we're supposed to end up with a water molecule. Now, in chemistry, this plus sign, it does not mean like a math class where it's a add. It's more like an and or a comma. It's a list. So I have a list of things when I start. I have a hydrogen molecule and an oxygen molecule, and when I get done, I'm supposed to have water molecule. So you can see that if I take 1 oxygen and these two hydrogens, I can make a water molecule, but this oxygen would have nothing to stick to. That's not okay. So in chemistry, the law of conservation of matter says that when you have an equation written correctly, all of the atoms had a place to go. I can't just add another 2 out here, because then I would not have made water, I will have made hydrogen peroxide. So what do? Well, if I add 2 of these hydrogen molecules, this hydrogen and that O, and this hydrogen and that O stick together, leaving these 2 hydrogens and that O to make 2 water molecules. Let's see if that worked. That would be 1, 2, 3, 4 hydrogens. I would have 1, 2, 3, 4. I have 2 oxygens and 2 oxygens. So to balance that, I would need 2 of those and 1 of those. And when I get done, I'll make 2 of those. Notice the coefficients tell you how many of each molecule you made. Let's try a couple more of those. Let's look at this top one. We have iron, oxygen, and it makes this compound Fe2O3. Well, right off the bat, I see that what I'm supposed to be making has two irons. So I'll put a 2 in front of the iron. Now I cannot put a 2 here because that implies that the 2 irons are stuck together as if they were a molecule. They weren't. They're individual iron atoms, and I need 2 of them, so I put that out here. When you put subscripts in, you're implying that something is stuck to itself or to something else as a molecule. Now let's look at the oxygens. There are 2 oxygens here and 3 oxygens there. Well, that's an odd number and an even number. If you think about how you're going to make that work, think about a least common multiple, which would be 6. To get 6 oxygens, I would put a 3 there. And to get 6 oxygens here, I'd put a 2 somewhere. Now I can't put a 2 in the middle because the 2 has to be in front of the entire molecule. So that gives me, as we saw before, 2 of the entire molecule, which would be 2 times 3, 6 oxygens. Now what that does is mess up the number of irons. You'll see now if this happens twice, I have 4 irons, which means I have to change this 2 to a 4. It may feel a little bit like guessing and checking when you have to go back and forth, but that's completely normal. Let's look at one final example. I have this molecule, C2H6, and I have oxygen. They're going to connect, or be taken apart actually, and reconnected. That's why this is a chemical change, because bonds were broken and new bonds were going to be made. I'm going to make CO2 and H2O. Can I make 2 different molecules when I'm done? Yes. So let's look at what we have. Well, there's 2 carbons, so I'll put a 2 out there. I'm picking 1 atom at a time and just balancing it kind of back and forth. That gives me 2 carbons and 2 carbons. Now if I look at H's, I'm going to save O2s for the end because there's only O2s, and as you get more practice, you'll see why that's a smart thing to do. Let's look at the H's. There are 6 H's there, so if I put a 3 there, that gives me 6 H's. Now let's look at oxygens. On this entire side, which they call the reactants, you have 2 oxygens there and none over there, so there's a total of 2. On the products side, you have, let's see, 2 of these molecules, that's 4 oxygens there, plus 3 more there, for a total of 7 oxygens on this side. Well, if I have to put a number in front of this oxygen to get 7, it'll never happen. This side will always be even. So this is about the only trick I know. If I have an even-odd problem, then I kind of double everything. So I'll put a 2 there, I'll change this to a 4, and I'll change this to a 6. Let's make sure I didn't mess anything up. That's 4 carbons now, and 4 carbons. That's 12 hydrogens, and 6 times 2 is 12 hydrogens. Now on this side, I have, let's see, 8 oxygens there, and I have 6 there. That's a total of 14 oxygens. So what I can do is say, oh, put a 7 there, and I have 14 oxygens on both sides. That's about as hard as they get, and we'll practice that a lot.